In this video, I'm going to give you an introduction to Venn diagrams in probability. And so we typically represent it by circles. I like to put the total of something at the top here and then the exact numbers on the insides. I like to write the total of everything at the top. So 50 people in this group, so I write at the top. 30 like apples, so at this point I would put the 30 there, not here, not here. 28 like bananas. Already, if you're new to Venn diagrams, you might think there's issues because that already adds up to 58, which is more than that. But it's fine because there are overlaps. 46 like either. So all that's telling us is that 4 people don't like apples or bananas. And so if I'm ever not sure how on earth do I fill in these 3 numbers here, I go back to my initial formulas. The probability of A or B, which is 46, is equal to the probability of A, which is 30, plus the probability of B, which is 28, minus the probability of A and B, which I don't know at this stage. And so if I take all my numbers across, I end up just getting 12. Now that I know that the people that like apples and bananas is 12, then if this total for A is 30, this must be 18. If the total is 28, but I know 12 like both, there must be another 16 left over. And so now I've got my whole Venn diagram and I'm ready to dive into the questions. Probability of A only, so like I've said here, that only refers to a very specific place. So who likes apples only? It's not the 30, it's just the 18 because they are not part of the banana circle as well. So 18 over 50, and you always want to basically punch your answer into the calculator and see if it can simplify it for you to a nicer, more understandable answer. Probability of A and B, and is just the overlap. So the overlap of A and B would be 12 in the middle there. 12 over 50 simplified is 6 over 25. This little line means not. So the probability of not being in B, and so if you cover or you cross out B, you're left with the 18 and the 4, which is 22. So 22 over 50, which simplifies to 11 over 25. This one's a bit trickier. The probability of A, so at the moment it could be either of these answers, but it must not be in B, so it cannot include anything to do with B. So I cancel that out, so it's just this. So it's 18 over 59 over 25. Some other concepts to say is that if you ever find you've got 2 sets of overlapping confusing information, it's probably a tree diagram. Like the percentage of people passing maths lit is this, the percentage passing maths is that, but when it's rainy walking to school or dry, the maths and maths lit marks are affected in this way. So when it starts sounding a bit convoluted and like I said 2 sets of information, it's probably heading towards a tree diagram. If you see them talk about mutually exclusive, it means there's no overlap, it can't happen together. So again, a typical case, although in rare cases it can, would be maths and maths lit. If I walk into a classroom and I say who does maths, you'll probably get a certain number of people, and who does maths lit, it will probably be a certain number of other people. And so the mutually exclusive formula is like this, but it just goes up to there. That's as far as it goes because the overlap is 0. And if they ever ask you to prove that something's mutually exclusive, you're just proving that the probability of A and B is 0, that there's no overlap. If you find that you're lacking information when you're filling in your Venn diagram, so this one was a bit easier, then just let the overlap of the information be X. Or if you've got 3 circles overlapping, let the overlap of all 3 be X. If you have a not question, you can do what I did where I covered everything and saw what was left to work out. Or probability of not being in B, I could have said it's 1 minus the probability that I was in B. And so it would be 1 minus what's the probability of B? 28 out of 50, and that would have left your answer of 22 over 50, and then you simplify it from there. So that's another way that you can do not questions. And if you add up all your probabilities, the total should always be 1. And so you might get questions where as a probability of A, they give it as 0.3, and the probability of B, they give it as 0.6. And you've got to work your way around there. Remember that the total, when you work out the probabilities, will always be 1. And so you could work your way backwards from there to work out everything. I hope that you found that introduction to Venn diagrams useful. If you did, please like this video, subscribe to our channel, and share it with your friends. Thanks.